Hi, this is Ms. Fitzmaurice, and this video is about two-object kinematics problems. So by the end of this video, you should be able to use kinematics equations to solve problems with multiple objects. First, you're going to see an example, and then you're going to try one yourself. Okay, so before we start solving problems, I just want to quickly remind you of the basic kinematics equations and what they mean. Okay, so our first kinematics equation, and you will at some point in your life know this by heart, is x equals x naught plus v naught t plus 1/2 a t squared. That's an a and a t. Okay. The second one is v squared is equal to v naught squared plus 2a delta x, and remember delta x is secretly the same thing as x minus x naught, and then finally v equals v naught plus a t. Okay, so these are the three main equations that you'll use when solving kinematics problems. Okay, and just as a reminder, x is position, v is velocity, and a is acceleration. Okay, so as promised, I'm going to do an example problem, and then you're going to try one, and I'm going to give you the solution. Okay, while I do the problem, I'm going to kind of give you a list of steps. Okay, these are not specific to these problems, but these are steps that you really have to follow when you're solving any kind of problem. Okay, the first step, and not to point fingers, but some of you guys didn't do this morning when nobody knew that the direction that things were heading was north, is read the whole problem. Okay, every last word. Read it twice even. Okay, don't fall into the trap of doing what your middle school math teacher told you to and just underlining all of the things that have numbers in them and trying to match the numbers together. Because that's not going to work out here, because there are too many numbers and they mean too many things. Okay, so here's our problem. We have two buggies, the little cars. They start from rest, a distance of 3 meters from each other, and start to travel in the same direction. The buggy that starts out behind has an initial velocity of 0, but accelerates at 0.6 meters per second. The buggy that starts out ahead moves at a constant speed of 2 meters per second. Where will the two buggies meet? Okay, so the second thing you're going to do is you're going to draw yourself a picture. For some problems, it might seem excessive, but overall, it's going to help you out immensely to draw a picture. Okay, so this is going to be my picture. I'll have different colored buggies. Let's say my red buggy is the one that starts out behind, and then my blue buggy starts out 3 meters ahead of it, so I have x naught equals 0 and x naught equals 3. And they both start going in the same direction. Okay, so they're both going this way, okay, I know that the buggy that starts out behind has an initial velocity of 0, so I know that my red guy has v naught equals 0, and the buggy that starts out ahead has a velocity of 2 meters per second. Oops, I'm supposed to do this in blue. Okay, so hopefully you can hear me over the washer machine. V equals 2 meters per second. Okay, the red buggy, even though it starts out going 0, we know it has an acceleration. It's 0.6 meters per second or per second squared. And then we also know that the blue buggy, it's moving at a constant speed, and what that tells us is that our acceleration is equal to 0, so we have a equals 0. Okay, we want to know where they meet. So we want to know where is x equal to x, because those are the positions. When they're equal, they'll be at the same place. Okay, and because I'm trying to set positions equal to each other, I probably want the equation that starts with position, and looking back, that's the one that says x equals x naught plus v naught t plus 1/2 at squared. So what I'm going to do is I'm going to write that out for each one, the red buggy and the blue buggy. Okay, so I have, for the red one, I have x equals, and I know that my x naught is 0 plus v0t, and my v naught is also 0 times t, but that's going to go away because 0 times time is 0, plus 1/2 0.6 t squared. Okay, my blue buggy, I'm going to have x equals my x naught, which is 3 meters, plus 2, which is my initial velocity, times t, plus 1/2 0 t squared. Okay, so I'm going to shift over to the next slide, but I'm going to take these two equations down here with us. Okay, so here are our equations once more. I'm going to get rid of everything that's 0. So this is going to go away, this 0 goes away, this goes away, and this 1/2 0 t squared goes away. And rewrite my equations. So I have x equals 1/2 times 0.6 gives us 0.3 t squared. And then for our blue car, or our blue buggy, we have x equals 3 plus 2t. Okay, when the two cars meet, these two x's will be equal to each other. So I'm going to set the equations equal to each other. I have x equals x, and I'm going to substitute in these expressions. So I have, and I'm going to start writing in black because it'll just be easier for me to do it, 0.3 t squared equals 3 plus 2t. Okay, now I can solve for t. It's a quadratic equation, which is kind of a pain, but I can get all of my variables on one side. Okay, so I'm going to rewrite this as 0.3 t squared minus 2t minus 3 equals 0. I'm going to go ahead and use the quadratic equation. So just as a side, that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so I'm going to do that in this case. My b is my 2, so for negative 2, so I have t is equal to 2 plus or minus, and I'm going to take the square root of negative 2 squared, which is 4, minus 4 times negative 3 times 0.3 all over 2 times 0.3, which is my a. Okay, so I'm going to go ahead and plug that into my calculator. Why don't you do the same just to sort of get back in the habit? Okay, and when I do that, I get two solutions. So I get either t equals 7.9, and I'm rounding a little bit, and that's in seconds, or t equals negative 1.26 seconds. Okay, these seconds are after the car has gone, and so only a positive time is going to make sense. Okay, so 7.9 seconds is after the cars have started. Negative 1.2 seconds is before they even started moving. So that's just kind of a mathematical artifact. A lot of times you have two answers, but you have to choose the right one. And 7.9 here is the right one. Okay, our last step is we're going to go and we're going to take this 7.9. We're going to take this equation that we had over here, and we're going to plug in 7.9. So we have x equals 0.3 times 7.9 squared. And when you plug that into your calculator, you should get 18.72. So we have x equals 18.72 meters. Okay, and that's actually a pretty big distance. Okay, so then the next thing I'm going to do is I'm going to give you another problem, and I'm going to have you try it. Again, spend 5 or 10 minutes max on it, okay? But don't bang your head against a wall if you've worked on it for 10 minutes and you're mentally done with it. Watch my solution. Okay, so here's the second problem. It says the bad guys are leaving in their getaway vehicle, which can travel at 60 meters per second. Iron Man will not permit them to leave and is determined to get to them in 2 seconds or less. If he starts out at a speed of 2 meters per second and is 300 meters from the bad guys, what constant acceleration must he maintain to get to them in 2 seconds? Okay, so take a minute, try this problem out. In a minute, I mean 5 to 10. If you're really struggling, don't struggle for a long time, but give yourself a good number of minutes to try it and then come back and see the solution. Okay, so now that you've gone ahead and you've tried this problem, you're going to see the solution. Okay, so again, first thing to do is draw a picture. Okay, we have the bad guys and their getaway vehicle. It looks suspiciously like my buggy boxes that I was drawing before. Maybe it has wheels or something. And Iron Man is trying to get them. Okay, we know that the distance between them is 300 meters, and we know that the getaway vehicle, it says it can travel at 60 meters per second. Probably they're going as fast as possible, so we know their velocity is equal to 60 meters per second. Okay, and I'm gonna say VB for bad guys. And Iron Man, we know that Iron Man has initial velocity, so V naught I is for Iron Man, is 2 meters per second. And we know his acceleration is equal to question mark. Okay, what we do know is the time that they meet is equal to 2 seconds. Okay, and what's important is if they're meeting at 2 seconds, that's the time both for Iron Man and for the bad guys. Okay, so now I'm going to set up our equations based on what we're looking for. So we want to know it's about them meeting. We want to know or set up an equation where is xi equal to xb. Okay, so Iron Man's position equal to the bad guys. That's the time, that is when Iron Man gets the bad guys. Okay, and based on that, I want to use the same equation that we used before. Okay, so I'm going to write it out a little bit different this time. All of these problems, you can do them about 100 different ways, so I'm going to try to give you a couple of ways for each type of problem. So I'm going to write it out as xi equals xi0 plus vi0 plus 1/2 ai, that's Iron Man's acceleration, t squared equals xb0 plus vb0t plus, and this should have a t here, plus 1/2 vb, or ab. Unfortunately, I'm not allowed to erase things, so this is plus 1/2 abt squared. Okay, now I'm going to go ahead and try to plug in some numbers and make this equation a little bit less complicated. Okay, so I have xi naught. Okay, what that means is I have to go through and decide where is my 0 going to be. Okay, for me, I think it's always convenient to pick the left thing as x equals 0. So I'm going to say Iron Man's initial position is equal to 0, and the bad guy's initial position, so x naught b equals 300. Okay, so I'm going to go ahead and try to plug some numbers in. Okay, Iron Man's initial position, we just decided that was 0. Okay, his initial speed, we decided that his initial speed was 2, so I have 2. And the time, I know that it takes 2 seconds to get to the bad guys. Okay, plus 1/2. We don't know what Iron Man's acceleration is, so I'm going to leave that as a variable, AI. And t squared, that's going to be 2 squared. Okay, now let's think about the bad guys. So they started out, their initial position, xb0, was 300. Okay, I'm going to add vb0t. Okay, their velocity is 60. Okay, and I know that it's 2 seconds. And I also know that they have no acceleration because that's as fast as their car can go. Okay, so looking through this, it's always important to remember what variable is it that we're trying to solve for. We're trying to find Iron Man's acceleration. Okay, so at this point we just have numbers, one equation, and one variable. So I'm going to keep going with the math. I have 4, that's the 2 times 2, plus 1/2 times a times 2 squared. The 2 squared becomes 4 times 1/2 is 2, and so it's 4 plus 2a, and I'm going to say AI for Iron Man, is equal to 300 plus 60 times 2. Okay, so that is 420. Okay, I'm going to subtract 4 from both sides and divide by 2 to solve for this a. I'm going to spare you the algebra, but I have AI is equal to, let's see, 420 minus 4 is 416, divided by 2 is 208 meters per second squared. Okay, this is kind of a ridiculous acceleration when you think about the fact that acceleration due to gravity is only 10 meters per second squared, or about 10. Okay, so hopefully this video was helpful. Hopefully you have a better idea of how to solve problems with two objects going towards or away from each other.